and welcome to Applied Mathematics for Business, CQMS 110. My name is Pauline Fu. In this lecture, we continue with systems of linear equations / inequalities. Topics include linear inequalities, solving system of inequalities by graphing, applications of linear inequalities. Finally, we'll talk about linear programming. Linear inequality in one variable. The linear inequality in one variable can be written in the form such as ax plus b smaller than c, or ax plus b smaller equal to c, ax plus b greater than c, ax plus b greater equal to c. The letter ABC could be a lowercase letter ABC. Okay, ABC are real numbers. The coefficient of x is not equal to 0. The examples of linear inequality include x plus 5 smaller than 2, t minus 3 greater equal to 5, and 2k plus 5 smaller equal to 10. How do we graph in an interval on a number line? So this is a number line. You are asked to graph x greater -2. So first, locate -2 on number line. It is this point, -2. Greater means any point after this point that is greater than -2. Okay. So you do this. Use addition property of inequality. For any real numbers a, b, and c, if you have a smaller than b, and you have a plus c smaller than b plus c, that means you can add one item on both sides of an inequality. If you add something in equality, you do not change the sign. The original is smaller than, you also get smaller than. But this is not the situation where you want to multiply a number by both sides of inequality. This is the next slide we are going to later on. Okay. So next, let's solve this inequality and using the graph. So first, both sides of this equality, we minus -5. So left-hand side is this one, minus -5x. You get 5 plus x because you collect like term of 6x, -5x. Right-hand side, positive x, 5x, -5x cancelled out, so you only have 8. So now, both sides minus 5, so positive 5, -5 cancelled out, you only have x on the left-hand side, and the right-hand side you have 8 minus 5 equal to 3. So the final solution, x smaller equal to 3. And this is the graph of solution on the number line. Okay, x smaller equal to 3. So use multiplication property of inequality. When you have A smaller than B, you want to multiply a positive number C on both sides, you get AC smaller than BC. You don't change the direction of the inequality, okay? However, if C is the negative number, if you have A smaller than B, you multiply both sides by C. You get AC greater than BC. See, originally you have smaller, but now you have greater because C is negative number. Let's look at this example. Solve 6y greater 12 and graph the solution set. Both sides we divided by 6 and you get y greater than 2. And this is the solution set on the number line, okay, y greater than 2. By the way, when you have greater, we use this roundly bracket. When you have the greater equal, we use square bracket. Use inequality to solve applied problems. In applied problems, usually you have keywords like greater than, less than, at least, at most. Those appeared on the applied problems. How do you interpret those key terminology into mathematical inequality sign? For example, a number is greater than 4. So you write down x greater 4. A number is less than negative 12. So x smaller negative 12. A number is at least 6, means x greater equal to 6. A number is at most 8, x smaller equal to 8. Let's look at an example. Brad has test grades of 86, 88, and 78 on his first 3 tests in geometry. If he wants an average of at least, see the keyword at least 80 after his 4th test, what are the possible scores he can make on that test? Okay, that is the question. So let X represent Brad's score on his 4th test. We need to find the average after 4 tests and add the test score divided by 4. That is the formula for average. So test 1, 86, test 2, 88, test 3, 78, test 4 is X. The average of these 4 tests is add them together divided by 4. And the average at least 80. So greater equal to 80. That means at least 80. Okay. So now we solve this inequality. Both sides we multiply by 4. But first, we need to collect like term. Those 3 numbers added together is 252. Okay, and then both inequality, both sides multiply by number 4. And here you have number 4 cancelled out. So left-hand side, you only have 252 plus x greater equal to 80 multiplied by 4, 320. And now you both sides subtract 252. You get left-hand side x, right-hand side 320 minus 252, 68. Okay. So the final answer is, the question is, what are the possible scores he can make on that test? the possible score is at least 68, okay, on his fourth test. So far, the inequality we see has only 2 parts. How about if you have 3 parts? For example, x between -1 and 2. Okay, so how do you graph this inequality on the number line? Remember the smaller sign, you use the round bracket. Smaller equal, you use the square bracket. Okay, so this interval represents x between -1 and 2, including 2. So last topic is the linear programming. And this topic, so what is linear programming? It is also called linear optimization. It is a method to achieve the best outcome in a mathematical model. The best outcome usually we refer to maximum profit and minimum the cost. This is the example. A manufacturer produces 2 products, air conditioner and fans. The assembling process needs wiring and drilling. Each air conditioner takes 2 hours of wiring and 2 hours of drilling. Each fan must go through 2 hours of wiring and 1 hour of drilling. Suppose 250 hours of wiring time available, and up to 150 hours of drilling time may be used. Each air conditioner yields a profit of $26. Each fan may be sold for $16 profit. Now write down linear programming to find the best combination of air conditioners and fans that yields the highest profit. And finally, you are asked to use Excel solver to solve this problem. Okay. This is a very good example or application of solving inequality with 2 variables, and also how to solve it using Excel. So let's, before we go to the Excel, let's write down the linear programming model. So the question asks you, how many air conditioners you should produce? How many fans you should produce that can maximum profit? That is the question. So let's use X represent number of air conditioner. Y represent number of fans. Okay, so we have 2 variables here. The question is, what is X, what is Y? Okay, so once we set up the letters X, Y, the variable X, Y, let's look at this sentence here. Each air conditioner takes 2 hours wiring and 2 hours drilling. Okay. So each air conditioner. So I have X air conditioner. So the wiring time for air conditioner is 2x. Okay. And each fan will go through 2 hours wiring time. Each fan will also need 2 hours. I have Y fans. Total number of hours for wiring is 250. So those 2 numbers plus together cannot exceed 250 because of the capacity. Okay. So this is the total number of wiring cannot exceed 250. Now let's look at total number of drilling. For drilling, air conditioner, you need 2 hours of drilling. So 2x is the total number of hours for air conditioner drilling. And for fan, you need 1 hour of drilling. So plus y. Total number of drilling is 150, smaller than 150. Okay, and what is our objective? Our objective is to maximum profit. So our objective function is maximum profit. Okay, what is my profit? When you sell one air conditioner, you get $26. Now you have X air conditioner. So maximum 26X plus fans. One fan is sold for $16. You have Y, so 16Y. Our objective function is maximum 26X plus 16Y such that 2x plus 2y smaller than 250, 2x plus y smaller than 150. Okay, and this is our linear programming. This one here is our linear programming. You have subjective function, you have constraints. Okay, and how do we solve this linear programming? This is a 2 variables inequality problem. We can solve it using the graph. Okay. So let's first graph this. Do I have space? Yeah, I will use this one here. Okay. So this is my y-axis, x-axis. This is my origin 0. So let's draw a straight line using the graph represent this constraints first. 2x plus 2y smaller equal to 250. When x equal to 0, y equal to 125. So suppose this point represent 125. Okay. Again, taking a look at this equation. When y equal to 0, x equal to 125. So suppose this point represent 125. Okay. Now draw a straight line through these 2 points. Okay. And this constraint said smaller equal to 250. Okay, means all the points here, all the points satisfied smaller equal to 250. This is just one condition. Okay, so let's see, this is condition 1, constraint 1. Now let's look at constraint 2. When x equal to 0, y equal to 150. Okay, so let's say 150 is this point, 150. When y equal to 0, x equal to 75. So let's say 75 is here. This is 75. Now draw a straight line between these 2 points. Draw a straight line between those 2 points. Okay. And all the points here, all the points are satisfying smaller than 150. All the points smaller than 150. Okay. Did you notice there is an intersection of those two straight lines? Okay. This intersection, if you just solve the system of equation, you can get 25 is x, y is 100. Okay. Out of those many pairs, many points, only this point can make the profit maximum when x equal to 25, y equal to 100. So means when you produce 25 air conditioner, 100 fans, you get maximum profit. So this is how do we solve a system of inequalities involving two variables. Next, let's solve the same problem using Excel solver. Okay. So I'm going to pull out Excel, and I also need to see the numbers. So I will want you to see both screens. I'll move this. So first, let's quickly set up some numbers. Air condition, fan. Okay. We have a profit. When you sell air conditioning, you get $26 for $26, and the fan $16. Okay. And you have wiring processing. You have drilling. Produce one air conditioner. You have 2 hours wiring, 2 hours drilling. And for fan, 2 hours wiring, 1 hour drilling. And you also have the hours. Maximum hour for wiring, 250. So you can see this context here. Maximum hour for drilling, 150. Okay, so we set up all the numbers. Okay, the question is, let's use this cell represent number of air conditioner. This cell represent number of fans. Now let's use solver. Okay, so before we use solver, we need to set up the profit function. So profit equal to maybe I'll type in the profit here, equal to sum product. I use this array with this array, means 26x plus 16y. Remaining days are x here, y here, but I don't write down x, y because this Excel only accepts numbers, okay? I also need to copy down the formula later on. So I need to change the cell reference to absolute cell reference so that I also get the constraint functions. Okay, so this is the max profit. Then I copy down the formula. I also got the number of wiring and the number of drilling. If I have number here, okay? So I will emphasize this is my profit. Now I'm going to use Excel. You go to data, data, and then solver. If you are using the Mac, you go to on the top menu, tools, you have data and solver here. You just click this one, you are going to have solver on your Excel. If you are using PC, you go to file, options, add-ins, and then you click solver. Okay, so anyway, so this is my solver. Okay, set objective function E3 to maximum by changing cell. This is my X, this is my Y, and subject to constraint, I add constraints. So number of wiring, number of drilling will be smaller, equal to 250 and 150 respectively. And click OK button. and make sure you select simple linear programming. And then you click solve, click OK button. See, you get the answer. X is 25, Y is 100. Okay, so this is using Excel solver to solve this problem. Okay. In summary, what we did in this lecture, we did linear inequalities with one variable. We also did linear inequalities with two variables. We just did that application problem, okay? And how to solve system of inequality by graphing. Applications of linear inequalities. We just did that air conditioner and fans, okay, with this linear programming concept. That's all for today. Thanks for watching.